Hello, in this video I'm going to talk about these robotic arms or robot arms in general. There are robot arms of all sizes and kinds, big ones that in factories can move objects the size of cars, to ones in humanoid robots from just about any imaginable size. There are, I think, two different types, especially when it comes to mobile robots or humanoids or other robotics as well. They can be divided based on the motors or actuators you use in them. Whether the actuators have a feedback of information or not, meaning does the actuator actually, can it tell the user or the computer its position, the force it's using, and other information. Quite many arms which you can find made with like servos like these ones online, they actually have servos which are standard from airplanes to RC cars and so on, but all of them have the problem that they cannot provide feedback about its own position. So you cannot know, you can give it instructions where to move, but you don't know where it is at the moment. You don't know about how much force it's applying or torque. So they are okay for a remote controllable equipment. So for example, many robots which have arms, yes, they look complicated, but on the other hand, they're nothing really more than remote controllable equipment, or in some cases just toys. So if you want to build an autonomous robot that's somehow able to by itself control and decide what it will do with its arm, maybe even learn new things, you need to get information back from the arms, just like we humans get information from our muscles, our joints, from our skin. The robot needs to get the same information. However, if you're looking for small scale arms, there are very few companies that make actuators that small like this, with decent enough price that give enough information back. I'm using here actuators from a let me see, these are dynamixel AX12A actuators, and some of them are 18 type actuators. It's a company, I believe, in South Korea. This dynamixel is a series of servos they're making. Pretty much otherwise the same kind of servos as the normal airplane servos, etc. But these are, you can daisy chain them, so you can connect them, instead of having huge amount of cables, you can connect the servos from one servo to another, in this case with a set of three cables actually, which are basically power and then just transmission of data. And it reduces the amount of cables needed. Also, because it's got digital transmission of information from servo to servo, and in the end, the last servo is connected to, for example, a Raspberry Pi, where you can download in a series of operations information from all the servos and also control them. And in this case, you can immediately, very quickly get information of the position and orientation of the different joints and the arm itself, which wouldn't be possible in normal servos. Of course, with standard airplane servos, RC servos in general, you can open up the servo and make some modifications to get feedback on the information, but in general that will be in analog form, and conveying that analog information through the whole arm to the controlling computer is a bit problematic, as it introduces a lot of disturbances into the signals, huge amount of cables, and a few other problems as well. There are a few companies which also make this kind of servos with the position and force feedback and this kind of daisy chain and digital control, but none seem to be selling very much. So far, it seems these dynamixel ones are the most popular. I have used during many years already, since the beginning when they started making these, even the most expensive ones. In the beginning they were a bit, let's just say, badly made, and usually the bigger servos than these ones I'm using is the smallest size they have, and the biggest ones of theirs, similar plastic looking lines, just bigger in size, they had enough torque that they actually broke their plastic encasing. Despite having metal gears, metal bearings and so on, but the torque was too much that they broke themselves. But I've noticed that year after year they've improved their products quite significantly. Though for a practical application, you can buy some of their more expensive servos, cost several thousand euros a piece. Okay, they're very well made, they have all possible features you can imagine, very strong ones. But for if you want to make, like in this case, there's 2 arms and each has so many actuators that if you have this kind of arm made from these more expensive ones, it will easily cost tens of thousands, maybe even tens of thousands of euros, the whole arm. So I opted for the cheapest one of these. Of course, the problem with these is the amount of torque. Therefore, the 2 of these, in certain joints, there's 2 servos parallel. These are from a company online, Crosscrawler Robotics, and you can buy very nice kits and these packages for them, even joint by joint, and these servo horns attachments. But I opted to modify it a bit myself. I upgraded some of the servos to be more powerful. How much it's able to lift and how well and the control, that's still a bit unclear, as they are unable to give exact numbers to themselves. But otherwise, I like the packages and the workmanship they have for their equipment. I modified that servo a bit on myself. I added some joints there, and this one I also modified. I added additional joints so that it's able to turn the objects in multiple directions, almost like a human hand, and still rotate the objects in front of the robot's eyes. So it's a bit of customization, as you can see from those parts, but making this kind of additions is rather easy for this kind of system. And the good side is that with these dynamixels is that if you notice that, for example, in my case, I'm a bit unsure. This servo system, as it's moving mainly parallel, I think I won't have much problem with the servo stalling or overheating, as is sometimes the case, as these intelligence ones, so far, most of the time, if they overload, overheat, they just shut down. But these ones here below, these might be crucial. Are they powerful enough? Will the plastic encasing, which is attached to the robot itself through screws, will it actually hold up to know how much weight? But with these dynamixels, it's relatively easy. You just buy more powerful servos and you can very easily attach to the existing system. And since the command structure system is the same in this, even in the more powerful ones, it's a relatively easy exchange to do. And the second arm, as the arm on this side was just to basically manipulate objects or to lift them or let the robot view them in the cameras. The target of this arm is basically very simple. The more simpler one is just to take an object from the ground and lift them and give them for the robot or the other arm to use. So it's like a dual purpose thing. The robot head uses the same dynamixel servos, and here you can see how they are connected. The last servo is connected in a chain to basically a circuit board like this, where you can put power supply, which is either with a switch and a connector standard RC battery, or you can put an external power supply here. And then here's another cable that goes into a USB adapter, though you cannot see it clearly from here, and it goes directly to the Raspberry Pi. So you can program the Raspberry Pi, for example, using robotic operating system ROS, easily to command these different joints and add your own controls on top of it.